Hi, my name is Devin, and I'm a rising junior at La Jolla High School in San Diego, California. And once again, for the remote program of Blue Stamp Engineering Summer 2020, I am doing the obstacle avoiding robot, which is Arduino. Today I achieved my fourth milestone and second modification, which was to integrate a servo, seen here. This is what makes it go left and right, to look left and right. And my modification was to integrate that into the design, and here's a brief demo of this now. Before moving on to bigger and bolder modifications, I wanted to at least get in the servo into the design, simply because I wanted the robot to make decisions for itself on where to turn, because I had it turn clockwise 90 degrees, so I wanted to make it have that ability to make decisions. And luckily, this was a process that wasn't that hard, because usually you see a servo integrated into a design early in a project, so it was simple enough to get set up, but then harder to integrate that into my full code for the apps on my phone. So to start, I created the holder, which is seen here. It's made out of cardboard, right here. And this may look simple, but I had no basis on which to design this on. I tried to look it up and see online what it looked like, but they were very obscured pictures, so I had to design it myself. And it took about 7 or 8 tries, and I actually made it out of the cardboard that Blue Stamp sent me. But after that, when I got it to work, it was really great, and it works perfectly still. And its job is to hold the ultrasonic sensor in place while it lets it look left and right. And it's attached to the servo on the bottom, so it's able to turn this way and this way. And how servo works is this micro servo is able to, I have it set at 115 degrees, and it's able to turn 50 degrees, then 170 degrees to look left and right. That's what I programmed it to, at least, but you can change it to anything if you want. Then attaching the servo to the Arduino was the next step. This was pretty simple because various diagrams online all said the same thing. They just plug it into a port on the Arduino, 5-volt port, and ground, and after that, you got it. So I just did that, and I ended up putting it into port 11, which was one of the free open ones. I actually only have one open port left, which is great. So luckily for me, the electrical component was done, or so I thought. You'll find out later that it wasn't, but electrical components are a lot harder for me because one wire could change the entire circuit, and it's just very difficult to find it. With this amount of wires, you see, it's kind of confusing. So now I got to move on to the software. Unluckily for me, there weren't really any projects that had an obstacle avoiding robot and a servo that had my type of Arduino board. So I just needed to start on my own, and I kind of got off to a rough start, but I got a pretty good basis. I started with if-else statements, and it worked okay, but it didn't actually work in the end. I mean, it looked okay on paper, but a little messy. So then my instructor looked at it, and all I needed to do was add integers, i.e., I created integers look left and look right, and the Arduino would then save this and then look, and then compare them. So let's just say the servo look left and look right. If look left was greater than look right, then the car would turn left, and that was my if statement. But first I needed to create those integers to measure that, to have the ultrasonic sensor measure. So then that worked after that, which was really great. And then the next harder step was getting this into the actual app. But again, luckily for me, this was also proved very easy, as these if statements and integers were easy to put in my previous code. But then came the worst part of all, probably the hardest challenge I've ever had to face in this entire modification series, actually project as a whole. First, everything broke down. I mean, the wheels started coming off, the batteries started becoming dead, and the whole project just stopped working. So I had to take a day or so to fix that. And then once I fixed all of that, it still didn't work. And I didn't even know why. It just was puzzling to me because my code was correct. And so I had my instructor look at it, and she looked at it and she was like, "This is all good. I don't know what the problem is." So then I was extremely puzzled again. So then I went to office hours of Blue Stamp Engineering, and all 13 or 12 or whatever of all of the instructors looked at it, and they couldn't see any problem in the code either. And so we were all kind of, what is this? So we kind of spent an hour or so trying to figure it out, looking it up online, and finally one instructor figured out that with the Servo library combination with the other libraries, the Servo library shuts down the PWM ports, which are certain ports on the Arduino of 9 and 10, which deactivated half of the motor driver and the servo as well. And so that's why the car wasn't able to go or move at all. So then all I had to do was rewire, and it worked. So it was apparently a problem that Blue Stamp Engineering students have been having for years, and we figured it out, thank God. So now I have a project that one has a voice command mode, which didn't change, but now the obstacle mode, where the robot can now make decisions for itself, which is a further step in artificial intelligence, which is a really cool project to be part of. The next modification will be to add a camera, but unfortunately I am waiting for that in the mail. So actually, the next modification will be to add LEDs. Right now I have a small LED that goes on when I get close enough to the sensor, but now I'll have LEDs around it, and it'll further accentuate this obstacle avoidance feature, which will be really cool. And LEDs from Adafruit are usually really reliable, so hopefully that'll be a fun process, and I'm going to use that as my next milestone, and then possibly a camera later if I have time. But that's it for today. Thank you.